Hello, friends. It's 10 a.m. in Redmond, and today I'm speaking English. And it's time for .NET API review. We have a bajillion issues, and all of these open tabs right now represent things that Emo put on our today's specific agenda, and we'll laugh when we only get through like 3 of them. So first up, get invocation list of multicast delegate without any allocation, 41849er. Jan?
Yeah, so this one went through a API review once already, but there were some, some feedback that needed to be incorporated. So the basic problem is that today the only way um, to crack open the delegate and see what it's actually invoking is this get invocation list API that returns array, and of course it means allocation. That's not super efficient. So we would like to introduce equivalent APIs that can do the same thing without allocations. So when you look at the use cases where people use this, like the very common case is that people just want to check whether the delegate is single cast or multicast. And the common pattern is like check whether it's single cast or multicast, and if it's multicast, do something more elaborate or slow. So I think it would be a good idea to have like dedicated method to checking for the single cast versus multicast. So based on the the use cases we have seen. And then the second part is for the multicast case is to add ability to enumerate all the invocation targets. And that's like struct-based enumerator that follows the same pattern as we use in a number of other places. The previous proposal had these methods as extension methods, but the part of the feedback was that it should better be on delegates. So the new proposal has these methods on delegates. And the last bit is we might also want to add a method to return the length of the invocation list, but I don't think this is like essential. I don't think it's really helping any of the use cases. So that one is just nice to have.
Jan, two questions. The length that would be like we wouldn't store that somewhere, or would we? That would just be an order and iteration if we had that.
So the way the delegates are represented today internally, we have like one way to return that. But of course, if we change the internal structure of the delegates, it might change. So that's kind of the downside of introducing this length API, that it locks us into particular delegate implementation.
And then you said the enumerate invocation list is for the multi-case, but I assume it would work fine for the single case to just
yeah,
necessary.
Yeah, okay. Yeah, of course, yeah. But of course, instantiating the enumerator and checking that the collection has just single element, it would take a lot of work in the JIT to optimize it down to the same code as the dedicated method, right?
Makes sense.
And just to confirm, if an invocation target is itself a delegate invoke method, this is not recursive, correct? This only looks at the very top layer of the delegate invocation list.
Yes.
Okay.
Yeah.
And I was going to ask why the new enumerator isn't an instance method, but I think I already figured out the answer, which is because you want the enumerated delegate type to be the input type and not just delegate.
Right.
So
we want to make it
getting
performant.
The generic specialization on the return.
Yeah.
Do we care about the interfaces for an IEnumerable or anything? Like, I assume the idea is you're just going to for each.
Yeah, that's one of the questions I have in there. Like when I looked at the existing enumerators like that, some of them do implement the interfaces, some of them don't. So, you know.
I mean, if it had the interface, you could use it in Link.
Yeah, you know, the question is like if somebody goes out of their way to create like allocation-free enumerator, you know, do they actually want to use it with Link? You know,
Right. At that point, just call get invocation list and save yourself the hassle. Yeah. Because the generic method is on delegate and not just multicast delegate, does that introduce complexity into the enumerator? Because now it needs to do the switch within the enumerator as to what the actual delegate base type is?
I don't think so. We have like the implementation between delegate and multicast delegate. It's kind of historic arbitrary split.
Okay.
But you know, we can. I don't see it as a problem.
Okay. I didn't remember if the whole like invocation list concept was in multicast delegate or not.
It's actually, if I remember correctly, it's implemented differently for every runtime.
Fair enough. Okay.
Can we drill in a little bit more on the is single, like the justification for it? Like I don't fully realize, I don't get it in my head why we need that property.
So when looking at the use cases, people very often want to special case the single cast delegate as a very fast path, and then do something more complex for the multicast delegates. You know, there is like somewhere in the discussion there are links to the existing places where people sometimes use private reflection to get this, and you know the check for the single cast it was kind of recurring pattern. It's not just one place somewhere. It's like it was found in several different libraries.
Okay, so like from my experience, like the enumerating the list, the most common case of why somebody wants to do that is to try catch around each invocation so that they ensure all of them get invoked, even if one throws an exception. Is that a pretty common case? And so then I linked one usage in the chat where somebody just says, well, if it's single, then I can just try catch around the one invocation, and I don't even need to fall into the enumerate case at all. Is that like the common case? Is that like the common canonical why we would want this property?
I think it's one of the cases. I think there are other examples where people do some reflection-based things, and you know, when it's single cast, it's like simple. There's no ambiguity, and when it's multicast, they do something more involved. So,
like they use reflection on the delegate itself, or are they reflecting into the delegate?
Yeah, basically they kind of use the delegate as they extract additional information from the delegates in some cases.
So a concrete example would be that naively you would call get invocation list and it would return the array, right? And you could for each over the array and try catch around each of them individually, but you don't want to take the hit of that allocation. So you use is single just to see if you even have to allocate the one element array. and if not, just dispatch straight to the delegate directly. Like that's the typical use case I see for it.
But if the concern was the allocation of the enumerator, that goes away with the
That
rest
goes
of
away.
the proposal.
Correct.
I mean, maybe if you were storing the results of some sort, maybe like the delegates are a func of T, and so then you wanted to store the results.
I've
Yeah, that
never
can be.
seen that in practice, but
Like a multicast
Sure.
func with multiple return values.
No. Well, yeah, I guess that's probably true.
So I feel that of the alternative names and the proposed name, that has single target is the best, because I don't know why we need to talk about its relationship status.
yes,
No laughs, really?
I appreciate it, Jeremy.
I'm funny, people. But while I understand is multicast, I would understand, which I guess is true multicast is saying, like, don't pay attention to the fact that the type says multicast delegate. But the is single, that wouldn't actually occur to me of what it was answering, but single target makes it a little more obvious.
Yeah, I kind of agree with that. I wouldn't mind as multicast, honestly, because it's just documentation, honestly, because you kind of have to understand it, but it's the terminology we use, so.
Yeah, because the type is basically is multicast capable, and this property is multicast for real.
Yeah, I mean, I think in practice it doesn't matter because people
Yeah.
don't really do, like, you don't type delegates as multicast.
Right.
Like, basically, it's a derived type that nobody ever interacts with. So in practice, you do delegate dot, and then if you see is multicast there, the documentation says, well, it's true if if it actually has more than one target. I think it's still fine, but I think has single target works better. I don't like it single either. It's a bit too wide.
I'm fine with is single. Like I was not okay like the other week with like invocation count because like that could easily be misconstrued to be like the number of times you called the delegate. But like is single, but yeah, has single target is also fine.
Yeah, I like has target a little better.
Yeah. So then what do we do? Has single target? Is single target? I guess has single target.
Yeah, probably the latter.
Yeah. By the way, do we have to use any type of co or contravariance annotation on the enumerate API, given that it is a delegate?
No,
would it be
because the delegate
incorrect?
could be a func, right? So we don't know anything about its covariance or contravariance, like as a whole. Like,
I don't think in this case it matters because you just return the one you were given, right?
are you saying?
Yeah, are you saying that in or out
The-
attribute on this
Oh,
generic
sorry,
type
for
parameter?
sure. Sorry. No, the
Oh, no,
delegate
I
types
just
themselves
misunderstood.
don't. Yeah.
Yeah.
The delegate types themselves don't have variance. It's the parameters for the delegate. That's what I was messed up on.
Okay.
Yeah.
Okay. We're good. We're good. Derp, derp, derp.
Yeah, and only interfaces can have the things, right? So anyway,
Okay.
So, do we need the length method?
Yeah, I was going to ask,
We
are we
decided on that?
keeping or killing the length method, and do we like its name?
I mean, if there are future possible limitations it imposes, and if Jan doesn't see a strong need for it, then I'd say we kill it until there's a strong need for it.
Yeah.
Sorry, kill what?
That sounds good.
I mean, what
Get
would you do with it?
invocationless length.
Presumably, you would just use it to allocate something to copy the enumeration list into.
Mm-hmm. Yep.
At that point, probably we should just have a method that does that, right?
I mean, you can already allocate, right, and get the list.
Well, you can
Yeah,
get
but-
the array.
Yeah,
I-
this
I think
would
it'd
let
be
you
for
put it into your show
scenario-
buffer.
I think it'd be for a scenario like was mentioned earlier, where if you have a func of t, and you want to allocate an array for all of the t's that might result if you had 15 func of t's chained together. So you call it get invocation list length, you allocate a t of 15, and then you iterate through the delegates, storing the results. And get invocation list length gives you that as a cheap operation versus having to first iterate through to do the count and then do it again, or as opposed to just using a list or whatever.
I kind of like that. It would let us get rid of the bool. Would we get rid of the bool
No, I don't
because
think
it's
so.
faster potentially?
Yeah.
Jan, if we just had get invocation list length, would it be reasonable to use get invocation list length equals 1 as opposed to
Yeah.
is single, or is that a
So it would be tiny bit slower, but not prohibitively slower in the current implementation in core CLR. It can, it kind of locks us into that particular internal implementation. It's probably not end of the world, but yeah.
I mean, yeah, because basically this is, since we keep talking about link, this is not any, and this is not count equal 1. So if the internals move to this has to become an ON operation, you're now doing an ON is in 1 versus a thing that it probably already knows a priori. So I wouldn't get rid of the Boolean if it's a thing people actually want to know. Having the Boolean, I think, is just goodness.
Yeah.
Is there a way that we can make those names more closely associated with each other so it's clear that? I mean, I guess there's a bunch of different ways to get at this list now. I mean, you can get the array, which is the old slow way,
Right.
and then these are the fast APIs that are just giving you kind of redundant information more efficiently.
Well, I mean, because this is the old name plus length to tell you how long the array would be if you called it, which is the same number of move next you would get off of enumerate. So I think it's fine.
So far the only change we want is has single target for the bool name, and everything else people kind of like.
I think so. Yeah.
Yep. And then I guess just to be double checking and not that I wrote something down without it being true. Nobody feels strongly that we should declare this struct type as IEnumerable and IEnumerator, right? Because if you care about that, just call the array one.
I would imagine, because you're boxing at that point. You can just get the array.
And if we're wrong, we can always add it later.
Right.
I think the note said last time we were saying it should, but I mean, it's just what we have done in the past. I'm not married to that.
I can't, off the top of my head, think of a time when we've added the struct enumerator to a place that there was already an array return, and so we're in an edge case of the pattern. If we're doing it for a completely brand new, this is the only way to enumerate your type, then yes, we generally do it. But here I'm fine with saying less is more.
Works for me.
Are we sure we want the length then with that strategy?
Yep, I think we want to keep all three.
With the less is more thought for one and not for the other?
Well, Steve had a reasonable scenario of you want to allocate space for your return off of calling a bunch of delegates. You want to know how much space to pre-allocate for your returns.
To be clear, I wasn't arguing for it. I was just giving an example of where it could be used.
Right. But I think it has a scenario, and that scenario is different than has single target, and it's different than link. And so I think they're all fine.
Have you ever seen a multicast func? Yeah, I'd be okay with removing the length one or not, but
So from the existing use cases that motivated this issue, I don't think there was any situation where the length would be useful. So,
Yeah, in that case, I'd argue we should just remove it and not constrain ourselves.
Works as well.
Sold.
thank you.
Thank you. All right. Consider adding task completion source dot set from task of task 4, 7, 9, or 9 or 8. I'm guessing Steve.
Yeah, it's me. So this one evolved a little bit. The basic where it currently stands is pretty simple. There are basically 3 methods on task completion source: set result, set exception, set canceled. And one of the common patterns you see, not the most common, but common, is you have some task and you want to transfer sort of its completion state over to another task. So you create a task and you hand it back and you give it to someone. And then that is just sort of a proxy representing something else that's happening. And when that other thing completes, you want to transfer its completion state over to the original thing you gave back to the user. And so you end up with a if task dot is completed successfully, set result task dot result, else if task dot is faulted, TCS dot set exception, task dot exception, etc. You have several if else's. And this is just encapsulating that into a little helper. So you say set from task, you give it the task, and it copies over that state from one task to the task completion source. And that's it. The try variant already exists in terms of set result versus try set result, or set exception versus try set exception. And all it means is that the set will throw an exception if the target task is already completed. The try just means return false if the target task has already completed.
this completion could race with other people calling other TCS methods, right? Or not
Hence,
race, but
hence the try.
yeah. But like, even if the try succeeds, it's possible that like the onComplete later will fail. Like
That I didn't understand that, Stefan.
so, for example, if I pass the incomplete task to a task completion source, right?
Sorry,
Like
this isn't about the try. Isn't about the task that you're passing in. It's about the task completion source.
I think I understand.
The task
all
you're
that
passing
means,
in. Sorry, just to be clear, the argument must be completed by the time you call this method. If it's not, it will fail.
okay,
It'll throw
good.
itself.
That's what I didn't understand. All right,
Okay.
thank you.
So I mean, so I don't quite understand the example then. So in the example that David lists here, it's basically the one method starts something.
Yeah, this is where I said the thing. This is evolved. This is not what David asked for initially.
Okay, I see.
He wanted what I was talking about, right? Where you could pass in an incomplete task.
Right, and I don't believe. I understand the goal of that, but you can achieve the same thing just by combining either await or continue with, and there are various issues you run into if you try and combine those into one thing. So my response down below was basically, I think one of my last comments on this thread was, I think they really need to be separated.
I understand, because that's where I was going to get to with the like kind of the indeterminate or undeterminable state that you might get in with that API and incomplete tasks.
Right, because you do this, and then what happens if the target TCS is completed in the interim? What happens then?
I mean, I think you just let it happen, but yeah, it's then would just like silently have no impact when the attached incomplete task eventually does complete. Like, I don't think it's necessarily impossible to design an API that way, right?
Yeah, but I mean the task.continue with TCS set from task seems an easy enough. Like when you're done, go
And
tell
easier
this
to document.
go tell this thing it should inherit your completion status, and if somebody else completed the TCS in the meantime, that'll throw, and that's fine.
Yeah, or if you don't want it to throw, try set from task. I think I agree that this is probably cleaner.
Just to confirm, two things. First off, this does not copy over the state object from the task that you're passing in, correct?
Correct.
The TCS already has. Okay.
Yeah, the state object is immutable at the time of a task's creation.
Okay. The other question I had is, I'll put my Jeremy hat on for a second. The only reason that try set from task would return false is that someone else has already called set, correct?
Correct.
So if the task is not complete, you straight up just get an exception.
If the argument is incomplete,
okay,
you'll get an exception.
All right.
And what does set from task? So what's the difference between set from task and try set from task then?
If the task completion source is completing the, let's call it task result. So task result must not be completed yet by the time you call these methods. If it is completed by the time you call these methods, try will return false and set will throw an exception.
So it's about the task completion source itself, not the...
Right. That maps to, so on task completion source today, there's a set result and a try set result method. There's a set exception and a try set exception method. There's a set canceled and a try set canceled method. Those are all about the TCS.
Gotcha.
Can we rename the task argument to like completed task?
Sure. It's reasonable.
Just as a, it does exactly what you would think.
Because it always throws, yeah, if it's not even the try variations. So yeah, it should be a completed task.
And in our terminology, completed does not imply succeeded, right?
That's correct. For better or worse, that's the terminology it started out with. It inherited that terminology from the earliest days with the with iasync result, which has an is completed property on it, which for iasync result just meant that the operation was quiesced. Didn't mean anything about how it completed, and then task inherited that terminology as well.
Yeah.
You could even put it in the method name, but I think I prefer it as in the argument. It's a little less verbose.
But yeah, I think you're still right, Stephen. Stephen, I think there's still a race condition. You could imagine if the task completes fast enough, it works, and it will suddenly it gets slower, it fails, right? But it's the
name of the game.
Yeah.
Chat asks if the task is not completed, it will assign the response when the task is completed. That's incorrect. If the task is not completed, it will throw an argument exception.
Correct.
If you want it to complete when you're done, use task.continue with. Okay, any other feedback? Sold. Add a string key dictionary read-only span of char lookup support. 27229er.
This is me as well. Is Jan still here? He depart. Jan's still here. Great. Cool. So this has been in the making for a long time. I think this issue was open in 2018, but we've had conversations about it even before that. The crux of the issue is here. Let's say you have a dictionary of string, comma, t value, and then you're using it as a cache. And the things that the keys, the strings that you have coming in, you actually have them coming in as, say, read-only span of char. It could also be a string with a read-only span of byte, or it could be a read-only memory of byte, or a byte array and a read-only span of byte. Whatever it is, you've got something that's sort of low allocation, but in order for it to be a key in the dictionary, you need to allocate some object to the string or the byte array, whatever it is. So you want the key, but then you want to be able to look it up with something else and kind of have a mapping between them. So you want to be able to say try get value on the dictionary of string using a read-only span of char, or you want to be able to say try get value on a dictionary of byte array using a read-only span of byte, or whatever. People end up writing their own collections for this, which is fine, but ideally you could just do this out of the box. So, but one of the reasons we've stalled on this for so long is lack of support for using ref structs like spans as generic arguments. And we, to this day, still don't have support for that. There is a chance, although I think it's probably a low chance, it'll happen in C# 13 and .NET 9. This proposal is basically assuming it does not happen, with a path to updating it if it does happen. And if it happen, assuming we add this in .NET 9, which I would like to, if that additional feature comes along in .NET 9, we can just update with minimal changes to take advantage of that constraint. And if it doesn't happen until .NET 10 or .NET 11 or whatever, we could add another feature to take advantage of it at that point if we want to. The way I've spec'd this out here is it's based on, rather than being able to map an arbitrary kind of alternative key type to a T key, you're mapping a read-only span of an alternative key to the key. So if you look at some of the APIs defined here under collection extensions, you'll see, for example, contains key, that the first line in the second block there, accepts a T key, a T value, which you're familiar with from dictionary, and then a T span element. And you'll see the key that's supplied isn't a T key, but rather a read-only span of T span element. So if T key were string, this could be read-only span of char, and the T span element would be the char. And this does not require any special, we can implement this today. This doesn't require any special language or runtime support around ref struct constraints. If in the future we did have a ref struct constraint, that wouldn't be T span element, that would be T alternate key, which would be constrained to be a ref struct, or to an anti-constraint, whatever we're calling it. It would allow ref structs, and therefore the implementation could only do with it what you can do with a ref struct. The way this works is we introduce an interface. I've chosen a name here. I'm not sure it's the best name, but IMAP span equality comparer, which you can implement on any comparer that you might otherwise pass to a dictionary or to a hash set or wherever. And in addition to implementing iEquality comparer, you implement this IMAP span equality comparer, which provides a few additional methods. It provides a get hash code and an equals that's based on a read-only span of the T span element instead of being based on a T key. And then it also includes a map function, which converts the read-only span of T element to the T. And so, for example, if in a dictionary you were calling, you called try add, if the key didn't yet exist, it would need to create a T from the read-only span of T-span element, and it would use map to do that. So each of these methods and collection extensions will check to see whether the dictionaries or the hash sets, whatever, whether the comparer that's in play implements this interface. If it doesn't, it throws. If it does, then it uses it. And we would implement this interface on basically all of a comparers to do with strings. So we'd implement it on string compare ordinal, string compare ordinal ignore case, equality compare of string dot default, and so on. In the future, we could also implement it on other equality compares if we found a compelling use case for it. We could implement it if we really wanted to. We could implement on string comparer. We could implement IMAP span equality of byte to string and say, okay, this is UTF-8 or whatever. But right now I'm just proposing the implementation would just do it for strings and read-only span of char.
Not
and then
also
we add
for arrays?
Sorry, Ben.
Not also
Sorry,
for an array to the underlying T? You mentioned byte array and read-only span of byte, and so I'm just curious if that's future projection versus...
Sorry, I just meant read-only span. I meant read-only span of byte and read-only span of char. So my proposal is basically we add a set of extension methods for every collection where this is relevant. And this proposal is proposing it for dictionary, for hash set, and for concurrent dictionary. We could add it in the future onto other collection types as desired. I had a question for Jan around instance versus extension method, because we could do these as instance methods if we wanted to. They'd be generic instance methods, a generic method defining a T-span element, generic method parameter, or generic method parameter, or how I currently have them defined as extension methods that take all three generic method arguments. That's the basic idea.
And I assume we want to have them as extension methods because the vast majority of dictionaries, unless they take strings, it doesn't really make sense to have those methods. Therefore, you just don't pay for them.
That was, my thinking was twofold. One is, but that's basically it. It's a size thing.
Yeah. And then the only thing is, why don't you have add? Why don't you only have triad? Because I guess when you do add, you have to allocate no matter what.
So my thinking was for add, either you're going to get an exception or you're going to call map. And either way, if you're expecting to get an exception, then use triad. Or if an exception is likely to happen, why are you optimizing for removing one allocation when you're likely going to throw anyway?
Right.
And if you don't expect it to fail, then why do you need to call the map method? Just call toString or whatever yourself.
And then presumably the only ones that would have to allocate is basically add, right? The other ones would all be allocation free.
Right.
I mean, modular the modification of the collection.
Right.
All right, Levi, I know you're in line, but I have like a super basic question. So typically T-span element is a read-only span car. I know, and then T is a string. Like, it's super basic.
That's like the 90% case.
Okay. And there's another case?
You could, for what we implement out of the box in terms of the compares that we provide, that's the case. But anyone could provide their own comparer and use this with anything they wanted. If you wanted a dictionary that was interning, you were dealing with read-only span byte UTF-8 sequences coming off the wire. You could do lookups in your dictionary based on your UTF-8 bytes and only convert it to a string when you didn't have it stored in the dictionary. So that would be a read-only span byte with a string rather than read-only span char with a string.
As long as you felt like writing the Git hash code to be correct.
Yeah.
Yeah, so these are done as extensions on the concrete types,
Yes.
there's no way to make this work for the the interface users, right?
I'm not aware of any other than type testing to the collections we know about and throwing for ones we don't.
Right.
Yeah.
Yeah, so I guess I'll just start in on my questions then. I had two questions. The first is that these extensions, I believe, allow you to pass a ROS-char, ROS-byte, ROS anything into a dictionary, regardless of what its T key is.
That's correct.
So, I mean, on one hand, why do we have a type system? But sure, whatever. Second question is, what happens if the underlying comparer is not an IMAP span equality comparer?
If
Like,
there's
are
an
we
exception.
So we're taking the cost of doing that check every single access?
Yep.
Is that acceptable?
The only other alternative I know about is creating brand new collections for every collection we care about here.
Well, one of the proposals that came up earlier was an extension method that would give you a view into the dictionary that basically said, like, I've already done the check just by virtue of you calling the extension method, and now I'm giving you a struct which contains the add, contain, remove
which
stuff.
returns a new collection type for every collection that we care about. It's just type. It's not new storage. It's a new type that it's a dictionary view that exposes all of these methods. And so it's still another collection type, just with an interesting implementation. And this doesn't prevent you from doing that in the future if the 1 or 2 nanoseconds that the type check costs is prohibitive. We can always add that in the future if it was really necessary. It has fundamentally changes your access patterns for these. So either you need to end up storing both the dictionary and that view, or you store just the view, and for things where you need the original dictionary methods, you call view dot underlying dictionary or whatever to access it, or you end up calling that. What I would fear would be you end up calling that on every access, which is actually worse than just calling these methods.
So, but what if instead of having IMAP span equality comparer, we have IMAP span equality comparable, and then string would implement this, and then there would be statics, and then you could constrain the T key to being that thing?
You wouldn't be able to pass a comparer in.
Well, I mean, in the same way that the comparer uses the comparable today.
But how would you implement ordinal ignore case? I don't
Yeah.
Well, you would have to still do the work on the comparer side as well, but you would basically say, like, in the same way that the T keys are comparable for the most part, like that would be the same there as well. Like, it just allows you to constrain the T key.
Well, this prevents the scenario that Steve brought up earlier, though, where you have some ROS byte, which is UTF-8, even though your T key is string, because string itself is not going to implement, like, statically IMAP span equality comparable against, like, byte.
I see.
So with like your solution, you would have to create some sort of wrapper type for every string that does like different comparable.
Which is
Well, you would
doable. It's
also
just
have to
work.
constrain the comparison, so.
So to your question, Levi, I'm not against effectively caching the type check in the future if it proves important. It just it feels like a whole lot of ceremony for something that I'm not convinced is.
But
for the 90% case critical.
Isn't is on a thing that's already been type tested fast?
This is inside a generic, though, so you have the canon type for everything.
I'm just saying we have smart people. We can make it.
Yeah.
Wait,
And-
what's the canon type though?
It's like dictionary of string int and dictionary of object int have the exact same JITted code.
But you wouldn't be
Stuff like
testing
that.
on that. You'd be asking if
Oh, you have the
dictionary_comparer
comparer,
is I mapped span equality comparer of
Yeah.
the span type and the
Yes.
target
yes.
I
So interface lookups for that aren't as fast as abstract base class lookups, but it is a thing.
I mean, these type checks have been made a whole lot faster than they used to be
Yeah.
in the past. I had suggested that Igor's recent work around PGO, because he's made it such that type checks with is and as now have a fast path via dynamic PGO. Jan
Nice.
was skeptical that that would work with this particular case, but I don't know that any of us have confirmed or denied.
Well, that's kind of what I was getting at about like all of the canon JITted code looks the same. Like you wouldn't be able to specialize really. You would say every single implementation of dictionary, any reference type, comma T, gets that exact same JITted check.
Right, but if the vast majority of your dictionaries are a
Yeah.
dictionary of string, then
if
Sure,
the only
sure,
time
sure.
you ever call the method is when it works, then the JIT will figure that out and
Yeah.
kick the new type
That
to a
is
slow
true.
path.
these type checks would also be in the highlighted methods on the screen, which if you're using them with a read-only span of char, there's an incredibly high likelihood that the dictionary is a dictionary of string, comma, whatever.
So the idea here is the comparer is responsible for working out how to make get hash code be the same, so that that's done a priori, so there's no notion of re or debucketing. And then, yeah, when you call try add and it needs to, then it'll call map to turn your span into a storable type.
Right. I wanted the implementation of equals and get hash code to be in the one place where the existing implementation of equals and get hash code was being done, so that it would
Right.
be a bug in the comparer if it differed in its results.
Right.
This makes sense, honestly.
Would it make sense to support frozen dictionary and frozen set as well?
We could. And there's also a question about immutable dictionary and immutable sets.
Yeah.
And my hope would be that the reason I was sort of opting for this approach of having these methods rather than the proposal of you call something that gives you some sort of view is a part of it is just to keep everything constrained. So we're just dealing with additional methods on existing types rather than new types for
Yeah.
every collection. But again, we could always add that additional collection type if it really proved impactful, and we can measure that in the same release. I mean, we can, once these are implemented, it becomes pretty easy to validate what the overhead actually is. I don't remember where we're at for dictionary lookups, but I seem to remember for a dictionary lookup of string whatever, we're in the 20 nanosecond range.
Yeah, I just remember a lot of work was done over the past few releases to like shave off nanosecond after nanosecond, like to the
Yeah.
point where we even pulled in like new implementations of the modulus operation.
Yeah, for 64-bit.
Yeah. So I guess going back to my first question then, if I type my dictionary dot contains key open quote hello close quote u8 close paren, that will now compile across every single dictionary instance in my application. Is that intentional?
Yes.
Okay.
Oh,
Is that desirable?
again, I don't know what the alternative is.
Right, like it's obviously not desirable that would compile. Right, I assume that would just immediately throw at runtime if it wasn't a string.
Yeah.
Or if you didn't have, yeah.
Yeah, I wish there was a way that we could make the extension method or instance method, whichever, not show up if it was not plausible, but there's no way to know the plausibility.
Because it depends on what compare was provided to the collection.
Right.
Yeah.
Because you could make a thing that compares your custom food to a span of, I don't know, nuint, And it's like, okay, well, you gave me one. I don't know why this works, but you made it work, so.
Do you have a suggestion on how to address that, Levi?
That's why I was originally a proponent of not doing these as extension methods, either having a specialty dictionary type or something else. But like, let's assume that's not going to happen. If the group, if this API review, council, whatever, is okay with the idea that that would always compile legally and just get a runtime exception, then so be it, right?
You can make T-key not generic, right? And say, no, we're only doing this for strings.
I mean, that would stop the byte array being mapped by read-only span of byte, or any generic T array, because I assume a quality compare of array is one object that we could make implement this to its element type. So it is limiting, and I don't think we can remove the constraint if we add it.
Right.
We can't remove the constraint?
Wait, no, you can.
Constraints can be removed in the future?
It means that you might be limited in the implementation of the method, but the callers of that method should still be okay. So if you have a generic method and you remove a constraint, it might inhibit your ability within that method to call other things, because those other things that you're calling might be dependent on the constraint that you had. But your own callers should be okay.
Because the constraint isn't part of the functions. That's why you can't overload on constraints.
Right.
We've removed constraints. Okay. We just removed some constraints in .NET 8.
Okay.
Yeah. These don't have to. I mean, we can. There are various dials we can turn here. If we really wanted this to only be for string and read-only span char, like we can make them literally just this dictionary string comma t value comma read-only span char. But that feels constraining.
Yeah, I like the byte scenario, but if I have a dictionary of int to int or something, it is a little odd that you quote whatever. Just
hey, if you want to make a comparer that maps int to span of byte and only says they're true if it's 4 bytes and is a memory overlay, then go for it.
It's powerful. It's just interesting, and I'm trying to think about how it would affect IntelliSense and so forth.
Mm-hmm.
I mean, it basically means, unfortunately, that they always show up, and I mean, they're basically all peers.
It makes me wonder if we wanted to make a weird sub namespace and throw the extension methods in there. Though I feel like modern IntelliSense doesn't care what you're using, say.
This is the if we really don't want all these things to show up, then for me that is an argument for going the route of introducing dedicated types that contain these additional methods. That doesn't mean the implementation needs to be that doesn't mean the implementation. I mean, it could be dictionary dot whatever dictionary. I forget what was the proposal with span lookup or whatever, and that would be the one method that you could get weird behavior with, rather than all these other overloads. I'm not moved particularly by the type check cost argument for doing so, but from a usability perspective, if we're concerned about the impact on every other use of dictionary, then that might motivate me.
I'm not motivated by that, because link. Every single one of these collection types it has link extensions by the hundreds. Link is one of the default globally imported namespaces in new projects, and it's one of the most common usings when you're not using global usings. So we're talking about, a couple new extension methods that you can filter out explicitly if you really want to, in IntelliSense for dictionary and hash set. That it's a super tiny in the scheme of things. It's not really going to bloat our IntelliSense for anyone, and we have the filters there if you want to not see extension methods.
I don't think people would actually filter them, and it's a little different than LINQ, right? Because they're overloads of extremely common methods on these collections. LINQ methods are generally seen as what they are, like they're well known in the .NET ecosystem, like, and they don't overload like anything that mutates the.
Yeah, I feel like they all also generally work.
That as well. Yeah, exactly. Like they do what they say on the 10, where this will just probably blow up.
The average case of the average input on either side is an exception. Now the average legitimate use case would be success, but that's the dictionary of int or of any numeric type. We would not in the box have any way that it would work, but it would still show up. But I can get entirely behind these are already going to be lost in a sea of extension methods. So you'll see them if you want them, and otherwise it's not like we're turning a 4-item thing into a 12-item thing. We're turning a 400 thing into a 408-item thing.
Well, it's like weird autocomplete on like add and remove and stuff, right? Like it's after you've already typed out the right name and you're looking. I mean, it's not the biggest thing in the world, but it's just like, what the heck is like a read-only span of key element?
Right. You'd be like, I don't know, but what I have here is the exact match of I have the key type, and so I'm going to call that one.
Yeah.
I think the most confusing thing for it would be if you are doing try-add on a dictionary of, let's say, int, and someone might think that it means what is effectively add range, try-add range, and that'd be the most confusing thing.
There's another potentially minor, potentially not issue as extension methods that are effectively overloading existing instance methods. The only thing that will go to the extension method is an exact match. Everything else will go to the instance method, which means if you have a span rather than a read-only span, you have a span of char instead of a read-only span of char. That will try and call the add instance method, or the try get value instance method rather than the extension method, and fail. You have to explicitly cast it to read only span for it to go to the extension.
You saying this from memory, or you tried it out?
I've tried it.
Weird, because I thought that my understanding of the mapping is it would say that your argument list is not compatible with the first one, so it would be eliminated and only the extension method would remain, and then it would say I can get there with an implicit conversion.
But it doesn't know what the generic inference would be. That's why it's not a match.
Fair enough. I mean, if we super cared, we could double overload it, and so we could intercept the span and send it to read-only span.
Yeah, that was one of my discussion points below.
But I think we could start with something like this, and then if we get enough people complaining about the why do I have to write a cast here, then we'll be like, fine, we'll write the interceptor for you.
Sure, I was just speaking to the
the consequences, yeah.
Another straw on the camel's back as we're
Right.
listing out straws for.
So you did mention the if we're able to take a ref generic parameter, a ref struct generic parameter in the future, that we could do something of overloading this, but we would end up with exactly two things that said read-only span of char in extension methods. So that I don't think we can do something fancier.
We wouldn't
if we
have
do
two
this.
things that said read-only span. We'd have one thing that was T ref struct and another thing that was read-only span of T span element.
But having read-only span of char would match both of those, and now you would get an ambiguous invocation. You'd have to specify. You'd have to whip out the angle brackets.
Or we choose a different name. Would it actually be? I guess because of the.
Because at the end of the day, read-only span of char would exactly match to completed signatures. And you'd be like, well, I don't know which one. Unless we made the other one an instance method, and then it would win. But
there's no ambiguity resolution between that?
Tanner?
Sorry, what is the other one?
If you have a
Yeah.
if you have a T and foo of T and a foo of bar or whatever, that both could match
Via implicit conversion.
via
being the same type.
Yeah, I think in this case you get an actual error. I think it's a typical thing with like where did I get this? It was I forgot which interface I implemented, but basically, yeah, if you have one interface where you have an instance method that takes the exact same thing as the T, and you have a T method as well, then yeah, you're basically screwed. The compiler will fail.
Could someone type up the code? I'm not exactly following, because if you've got something that's generic and not generic, the non-generic one wins because it's more exact. And the extension methods always lose out over instance and direct methods. You can't have both a static and instance method of the same name.
So this is the future projection. So it's right now we're discussing adding contains key with key value and a span element, taking read-only span of a span element. And if later we're able to take a tref struct, and you can say read-only span of char here, these two things after when you call contains contains key of char span, both of these would be equally legitimate.
Isn't it, Jeremy? I put an example that compiles today in chat. Is this not the same case we're talking about? Is there something that makes what I wrote different? It's possible.
Yeah, and what Steve wrote in chat, that will target the second, the last method, the IEnumerableT method, when it's compiled.
Yeah, I think it resolves because it considers it considers the second one a more exact match. I think this was Jared's here. Jared can answer.
You have summoned.
Oh no, what's the question? I saw span and generics,
Yeah.
and
Okay.
given that's up on LDM's agenda, I thought.
So
we're talking about if we were to add in .NET 9, let's say the feature you're proposing, Jared, or you're working on doesn't end up existing in C# 13.NET 9, and in .NET 9 we add as an extension method on dictionary, basically what Jeremy currently has highlighted on the screen. If in .NET 10 and C# 14 we then wanted to add the next line where tref struct was whatever allows tref struct : ref struct, or whatever the constraint or anti-constraint looks like, would that result in an ambiguity for someone passing in a read-only span char?
I don't think so, because non-generic. If it were generic and non-generic methods, like non-generic methods are preferred over generic methods, but I don't think we have. I think the tiebreaker extends to parameter types too, so I believe we would pick the first one just on the basis that it was less generic. But
which is that's what the Sharp Lab example suggests as well.
Yeah, that matches my generally the tiebreaker is pick the less generic one.
And read-only span of T-span element is less generic than tref struct.
Yeah, one is that's a type, like you're matching a type parameter versus a non-type parameter. So the type parameter, we look at the original thing.
So the composed generic is less generic because it's more constrained. Okay.
That's overload resolution's really complex. Weird things happen. But
no. Like, this is just making sure we're not picking a thing that we're shooting ourselves in the foot for the next version.
No, but this would just also, even this type of like general problem is the thing that like binary compat or like lower overload precedence is trying to solve, of how do we just tell the compiler like we regret our decisions and wish we could do something. We regret our previous decisions and would like to have new things. So I think even if you dug, like, this is something I know, like Fred and I have been talking with Steven about how to solve this idea of like, we add new methods and we have these old overloads that keep getting bound to, and how do we basically say like, please don't use these if you can. Please use other things if they're available. But yeah, I think this is generally seems safe, but especially if you have a sharp lag example that matches the intuition there.
Matches the intuition, I see.
Listen, it's like if someone claims they understand C# overload resolution, it's not John Skeet, Neil Kafter, Mads. It's kind of like people saying they understand C++ template programming. It's like, it's a lie.
This is why I started talking and was going to say roughly what Jared did, but then I saw Jared was here, so...
Yep. Okay. So that is correctly not a concern. That's good.
Well, this is a concern that it took us 20 minutes to talk about it.
No, but it's not. It's not limiting, and we don't even have to change overload resolution or add a compiler feature or whatever to make it be not limiting in the future. It's currently not limiting because they're generic to different degrees, or some other version of that terminology that is correct. They're different enough that overload resolution says one of them will win.
So, Stephen, like you have seen enough of this work, but like, would roles solve part of this problem of not having to introduce new types? Not really, right? We still have to have a type that represents the role, right?
Yeah, I don't think it solves anything. I mean, the fundamental concern that I've heard voiced in different forms is these methods might fail at runtime. They basically let you pass anything in, and then they might fail if the comparer that's in the dictionary or in the hash set doesn't support it. And I don't know of any solution to that other than new types.
Or separate method groups, but that seems equally ugly.
Well, no, because if we wanted the type system to tell you that this was feasible, we'd extend dictionary with map span equality dictionary that took as a required parameter an IMAP span equality comparer implementing comparer, and then now you have one. You just have to now go change all of your new dictionaries to new mapped dictionary just to get the method to light up, which would be... feels like overkill.
And you might not be able to change those because they might be provided to you by another API.
Yeah. And so now you're inserting the dynamic casts in your code, which is probably worse than calling this in the first place. Because from a new developer, let's say you're in a function that's got both ROSByte and ROSCHAR, you pass the wrong one in, you get a runtime exception, you fix it, right? So when writing new code. For once you've started calling it, the only way it would fail is if you now got a dictionary that used a custom comparer that didn't have this feature when you wrote it on one that did. And like, I don't care so much, I think. So while it is a little bit of noise in IntelliSense, given that there's the sea of extension methods from Link already, and it feels just like an accident and not like a, oh, I totally thought this would make sense. When you call it with the wrong input, like, I think I'm fine with it the way it is, even though it is a little warty.
It means it's now a breaking change for us to return a dictionary in .NET 9 that has string comparer ordinal ignore case, and in .NET 10 string comparer some custom ordinal ignore case where we happen to forget to implement this interface. That would be a runtime breaking change.
That's true. That said, changing the comparer is already a runtime breaking change in certain circumstances. If someone's calling dictionary.add and we'd returned a dictionary that was ordinal and we would change it to be ordinal ignore case, that add could now blow up because there are now duplicates where there weren't previously.
Well, it's entirely possible, and I've seen this in production systems, like Visual Studio does this all over the place, where they use a custom comparer that is behaviorally identical to the existing comparer, but highly optimized for the scenarios they care about.
Yeah, no, I get that it's another example. I'm just pointing out that it's already the case where changing the comparer can introduce exceptions where you didn't previously have them.
I'm saying that there is now a
extending
concern.
it further, but yeah.
There is now a concern beyond. Not only do you have to maintain behavioral compatibility, which you're right, that would have broken you anyway. You now have to have this interface compatibility as well.
Yes.
Yes.
If some part of the system wanted to use the span-based lookup.
Well, if you're returning it from your API, your caller might be expecting that.
To be clear, that is the case with the alternate proposal of deriving from this as well.
Oh yeah.
Yeah.
The only thing I'm aware of for that is top level collection types for every. We have a new dictionary type. We have a new concurrent dictionary type. We have a new frozen dictionary type. We have whatever, which I don't think is a path we want to go now.
No, I agree.
No.
Yeah, and that's the notion that you're calling a library and then they changed what comparer they're using and the thing they return back to you. Again, it's like, well, you would just file a bug on them. Like, yeah, you get broken. That happens.
So there is like a third option. Not saying we do it, but like change the core collection types, but hide the methods, right? Like don't make them extension methods. Like it's still in the core collection types, right? But you just
put them on an extensions type that's in a sub namespace and not imported by default. Is that what you mean?
No, I mean like literally just make them static methods without this parameter. But like, I'm just saying it's a third option. I think that the extension methods are probably better.
Just so the ceremony is more complicated?
Yeah, or just so like it's like kind of a niche use case. It's weird to accept. I'm probably, again, it was kind of a straw man kind of thing, but I just wanted to discuss it. I'm just looking at the problem of having like non-string like keys that now accept like Unicode string literals. Basically as keys, but as far as like the overloads are concerned, like it's just a little odd. It's like super easy to do without like any setup. Now any dictionary will IntelliSense your way potentially if you want. Like it will compile to just accept a string key. It's just a little odd.
Yeah, fortunately the problem's not that bad. Like if you pass a string literal, like it's not going to compile. You have to have explicitly a RAWs.
Yeah, or but it's pretty. Yeah, you're right. Not many people use that.
So maybe we're just overthinking the issue. Maybe like you said, so few people will use it that it's just a non-issue for that population of our developer audience. I mean, I would be willing just to go forward with this in .NET 9 and just see what happens. Like, we're in early previews. If it ends up being a huge problem in practice, we can always change the design. But like, this is the time where we're supposed to be making these kind of more interesting, potentially more risky changes, right?
And I do have it prototyped out, so I could get it checked in pretty quickly. I need to sync with you on one thing around your favorite subject right now, the binary formatter.
Okay.
But that I have one issue that I'm not like 2 failing tests in the binary formatter library that I need to figure out. But
okay.
Yeah.
Fun times.
I
Okay.
have a different question. So, like, so I understand this is an older issue that got a lot of likes, but do we in practice think that a lot of people were going to use this API?
Yes.
I've
I
written.
do. I mean, I think it is. Even outside of this issue, I see it come up. No, we just saw one on one of our internal discussion was someone asking, how do I, I'm working with slices and data coming off the wire and whatever else, and I want to be able to cache stuff without incurring a string allocation just to look up something in my dictionary. And that's basically what this is intended for. It's I'm generally low alloc, I have a cache. How do I avoid allocating to look up in my cache? And the solutions people entail today basically are you create your own key that is some kind of discriminated union between a string and an int putter or something. And then you pin your span, you create your struct around that pointer, and you have your own comparer that validates, that does the comparison. It's possible. It's just really unintuitive and hacky.
It does bad things if you call add.
It does bad things if you call add, yeah.
And if you take stuff off the wire, you end up running into interesting problems where what happens if the data is malformed? What does Git hashcode do at that point? Does it try to fix it up? Does it throw an exception? Like, if it tries to fix it up, will it never compare as equal against anything? And will it try to re-add it to the dictionary? Stuff like that.
Yeah, I've definitely seen it with wanting to, whether it's I wanted to do avoid substring and use slice on a string, or that I have the data in something other than the exact bounded string, but string is more or less the natural type for keying a dictionary, and it's like, fine, dot toString, and
I mean, to your question, I think it's, as with spans, only 10% or whatever, I'm picking some number of developers will be using spans directly. I think this is similar. Most uses of dictionary will be unaffected, but there will be a subset of the population that use spans where this is really, really valuable. That is my intuition, at least.
And is the maintenance burden of like a span optimized dictionary and hash that type just way too high?
They're just
It's just you don't want to
ecosystem damaging for no, like, everyone who wants to use it would have to change to it. If you're getting a dictionary from somewhere else, right now, if somebody has a dictionary of any of the intrinsic comparison types and you have a view into it, you can ask these questions without turning your substring into a full string, etc. And
as long as you don't have one from Visual Studio where they replace the default comparer. Yeah.
That's why I said if it's using one of the built-in comparers.
Yeah. No, you did qualify.
Well, they can't. They literally cannot use one of the built-in comparers.
Right.
But yeah.
And so, does dictionary, do all the types expose the comparison?
I believe they do.
I mean, the
It
compare.
was needed.
Sorry,
it was needed for serialization, so I'm sure we did it.
Right, because it means that somebody can guard the check if they wanted.
Yes and no. I don't remember if we fabricate a comparer if a null compare is passed in.
I think we just return compare to default, right? Don't we?
Yeah, we use
For a dictionary, we end up doing a clever thing where we create and cache it for reference types, but for value types we don't, so generic specialization can kick in.
Yes.
we
For
still
value
use the
types, we always do a quality compare of t.default directly, rather than caching it.
Right.
We still use a quality compare of t.default. It's just a question of whether we've stored it into a field or local first.
Yeah, like,
Yeah.
Is there a property hanging off dictionary that is here's the comparer I'm using, and
Yes.
will they see null
Yes.
or a thing that they can do the type test on?
We also
They'll see null.
No.
No, they see an actual thing. They don't see null.
they see default, which also Levi also put some optimizations in there to switch over. I think it was Levi to switch over until there's a conflict that switches over to a custom internal comparer. It still surfaces it. It still says, if you pass in string compare.ordinal, it still exposes that .compare is string compare.ordinal, but internally, until there is a hash conflict, it uses a different compare internally, but that's an implementation detail.
Yeah. As an implementation detail, like, we might lie about the compare to you, but it will be behaviorally identical. That circles back to what I mentioned earlier. Like, if a compare is behaviorally identical, you need to make sure it also implements this interface, or else people will get really confused.
Could we do like to kind of kill two birds with one stone, like a two span key kind of method that validates all the generic parameters, returns a new type based on two-span element, and then exposes like all of these methods?
Yeah, that's the alternative that was proposed later down in the thread, and that we were talking about. Is it still requires a new type, but it's sort of not a top level thing per se. You still end up with one of these per dictionary, but you would call some method on the dictionary dot with span lookup or whatever, and it would give you back that new type that then buries all these other ones. The motivation for that proposal was to avoid the type check per call.
Mm-hmm.
It also has the possible usability benefit of avoiding putting all these things on the main one, but the downside usability, if all you're doing is using these new methods, then it doesn't really hurt anything, right? You change the place where you're storing the dictionary, you change it to store the wrapper, and then then you use it. But if you were using a mix of them, either you store both things and you go to one for one and the other for the other, or you have the wrapper expose the underlying dictionary, and then you call wrapper.dictionary. Whatever to access the original thing. So it adds its own usability downsides as well.
And the method, like the with span key method or whatever, would need to take the generic parameters explicitly then, probably, where these could be inferred a lot of the time now.
Right. Yeah, you'd call it with span open bracket char or something.
Yeah, I mean, that seems okay with me too. I don't know how much of a performance impact that really makes. It seems like not significant in your mind if that's not the primary proposal.
I mean, we can measure it. I would be surprised if it adds more than 10% to a given operation. I'm throwing out numbers, but
sure. But I mean, this is people who are obviously very concerned about perf, but I'm sure they would get, the perf gains would be dwarfed by the slight cost of this type check. Can we scroll down? Like,
I was gonna say, do you have that written
out?
as a?
Yeah,
I don't have that fleshed out. No, there was a proposal towards the bottom from, I think his name was Alexander something.
Yes, this was one of the really early proposals, really early proposals, where you have an extension method that returns a struct that wraps the dictionary, and the existence of that struct guarantees that the dictionary has the correct shape inside of it.
But it's the create or to or whatever method that still does a runtime check.
Right.
Yes, and that runtime check is done once, and then you store the struct.
Yeah. I mean,
Now, if you
the way
put
that this
it
is proposed
directly-
here, you need to specify all 3 parameters.
Correct.
Yeah, but you can make it an instance on dictionary and only
Yep.
take one, right?
Yep.
So. I don't mind this. I almost, I don't know. I kind of like it.
You like this better, Stefan?
A little bit. I mean, you know, it's like an extra line of code and stuff, but I'm not as swayed by the link ruined our intelligence, so let's give up on the people who aren't trying to do anything span related thing, kind of, you know.
Yeah, I mean,
unnecessary things.
we would need a new proxy type for everywhere we ever wanted to do this.
So 2 places right now, hash that in dictionary, right?
And concurrent dictionary.
Like
And then
dictionary, hash set, and concurrent dictionary. Frozen dictionary was mentioned.
Okay.
There's probably frozen hash set. So basically every major collection type.
there's also the what would we, how would we feel about those collection Marshall ones in the middle? We put those, I believe, on Marshall. The existing ones are on Marshall because they return a ref into the original dictionary, which if it's been grown separately, they might no longer be valid, or it might no longer point to what you hope they're pointing to.
Mhm.
What would we do with those?
I think they would have to target, like right now, it would have to target dictionary, hash set, whatever. It'd have to target the proxy elements.
So these would
And like
still
when
be
we're,
these would
Oh, sorry.
still be on collection Marshall, but instead of dictionary, it would be span proxy dictionary or whatever.
I would probably do it that way. Yeah, and like adding a new struct, I don't think is like the end of the world if you're like adding 10 other members anyway. Like the, you know, encapsulation of it's kind of nice.
How would we feel about in this theoretical world where we added these types? How would we feel about them being nested?
I'd be fine with that. I guess people who write out types more. Yeah, I mean, you got to write it out if you're going to store it in a field and stuff. But I personally would be fine with it. Just give it a short name.
I know we don't like them.
I think for specialized things like this, I think I'm fine with that. It's also like, it strikes me as I kind of agree with what Steven said earlier about, to me, it's not about the cost of the runtime check. It's more about the getting a view that doesn't pollute IntelliSense for everybody else.
So a Stefan.
Well, it's
You
not
can
about
distinguish.
IntelliSense.
Oh yeah.
It's about like, in theory,
API
we
does.
shouldn't make code compile if it's not going to work at runtime.
Well,
Yeah, my
If
problem is,
possible.
Well,
so my problem with
This can
Link
still
is,
break though.
get proxy of T will still be capable
Yeah.
of failing, but we've now reduced it to one failing place.
Right.
yeah, my problem is, I guess, silent failures, right? So like, I don't mind seeing span showing up in IntelliSense. That seems fine. In the same way that I'm generally fine with link showing up. The problem I have with link showing up, that some methods like contains are now an ON operation and you were not aware of that, right? And the same way here, it's like, oh, you call a method that IntelliSense advertises to you, but it actually doesn't work at runtime, right? And I think it doesn't work at runtime. I'm also fine with that if the audience that calls it kind of had to jump through hoop to call it in the first place, right? So for example, the one on collection Marshall, zero care. I mean, you call a very specialized API. If it doesn't work the way you want, well, too bad, right? I think the combination of having these widely used APIs and then putting something else next to it that might not work in all cases, that I think is the big no-no. So if we have an extension method like I don't know, with span lookup or something, or extension method or method or whatever, and it returns some sort of nested struct that gives you those methods, and they still do a runtime check and might fail. That I also feel is fine because you opted into them, right? You literally call the specialized API, you get specialized behavior, it comes with fine print, you got to read it.
You're making a distinction between an extension method called with span lookup and extension method called try add.
Yeah, because to me it's like, so try add is kind of, it overloads a very widely used method. I mean, maybe not as widely used as add, let's say, but they all compete for the same kind of widely used methods on those collection types. And so they're advertised in IntelliSense even though they might not work, right? That to me is the unfortunate thing. Now, if we could somehow say they only show up when you can use them, I think it's fine. I mean, if you don't care about spans, then don't use it. But if you do use it, then it's fine. It's the combination of they advertise and they may not work, and the place where they advertised is prominent. I guess that combination I don't like.
I like the namespacing too. Like you could look at, when you look at the API docs for dictionary and it shows you all the extension methods, like sure, you could, control F for read-only span and you'd find these. But to have them all next to each other in a single struct, I don't know. I think it's just cleaner.
Okay, so what namespace would you pick for those?
Well, this is why I was proposing nested.
Mm-hmm.
Well, I mean, yeah, a new namespace I think would only make sense for if we were keeping the extension methods and we're the way they are, and we're just trying to make them show up less often.
Yeah, that's what I thought I heard. It's like, we keep the current shape, but instead of putting it on collection extensions, we put it on a new type that we put in some namespace that isn't imported by default.
Right. System, collections, generic, span.
Yeah, but we were suggesting that the new type could be nested inside of dictionary set, whatever.
Sorry, I thought we were still talking about the proxy approach.
Yeah, I think so. I think there's some cross wires.
Right.
I don't think it has to be static methods. I think they can be like instance methods on the proxy nested struct thing.
Yeah, that's what I would do. So I would say if we had proxy type, then I don't care that they don't work in all cases because while there are proxy types, you opted into them. It's fine print. And then I'm even fine with that extension method that gives you those proxy types or instance methods even just always being in IntelliSense because it's no longer a prominent API. You had to call this brand new thing, with span lookups or something that comes with fine print. That to me is fine. And then the alternative to that is the current approach, but instead of putting it on a type that is already imported, we put it on some other type that is not imported by default. And then the opting in is you have to using to this esoteric namespace. And then they overload to contains key, remove, try, add, whatever, right? But you had to somehow get them.
Right. It'd be something like this.
Right.
Yeah.
With
And right, I looked at FDG to see if it said what languages are bad at nested types. C# is fine, right? Well, because you'd end up with like dictionary of string to foo dot span proxy of char proxy, which is that might be one of the few places that I agree var is okay.
Yeah. I mean, the question is, are you going to pass this guy around? I don't think you do.
I don't think
I would.
I think you would expose off of span proxy the underlying dictionary, so you have a property that is underlying or something, and if you needed to pass it, you'd pass that thing. That's also how you'd get at. Like if you just wanted to store one thing, you would store the proxy, and then if you needed functionality in the underlying dictionary, you'd call proxy.dictionary.
Right. a single field property struct, right?
Yeah.
And just expose it.
Right, because contains key
But
would
then
then
it's
just
kind of
be
if you really want to optimize the type check, right? Because if you don't care about the type check, you would just have every time you want to do the lookup, you would just do get proxy, right?
I mean, you can still optimize away the type check. We own dictionaries, so we know when we know what its implementation does. We know that underlying if the creation of this proxy type succeeding, if you have one of these proxy types, then it means the dictionary's compare is correct. So we could do unsafe tricks to avoid the type check on every use.
No, I meant more like for the user, right? So so assuming we would do that, right? But then does the user actually care as much, or would the user just? I mean, I would say you'd be fine saying dig.getProxy every time you want to do the span rest lookup. You really need to optimize that and just store the proxy all the time.
right. So
Because I think if
the
because
data's coming in, and you're like, if dict.proxy of char.try get value.
well, I mean, I wouldn't go that far, right? So if you assume this whole thing runs in a loop, I would hope you hoist the local out once,
Sure.
right? But I, you know, I would think most of the lookup happens in the context of a method, right, where you have a loop, right, and then you put that outside the loop, and that's as much optimization as you need.
I'm not sure that assumption of it happening inside a loop.
I mean, that's fair. I mean, okay, let's say it doesn't. Then is it really that bad of a person?
Right,
My
but
argument was no, but if you're going to be storing something, you might as well just store the proxy.
Yeah, I think so. The reason I'm bringing this up is because if we collectively think, generally speaking, no, then to me the aesthetics of a nested type don't really kick in, right? Because then it's just like an enumerator where we already have nested types, because we generally don't expect people to pass them around. You can. There's nothing preventing you from doing that, but it does seem like you're no more in the, you know, I don't know, 1% case, so we accept that the type name is slightly ugly, right?
Yeah, I don't have a problem with nested types in general. I know some people think they look ugly, but it's like basically the same number of characters.
Yeah, I mean, it's more like the discoverability and other things. Like, and every time I do environment.special folder, like, kind of throw up a little. But yeah, that's fair.
yeah, I thought that FDG said that, or pointed out that, you know, like VB or COBOL.net or something had either difficulty or addresses them differently, right? Because when you look at the toString, that says plus instead of dot, because it's indicating a type relationship, and I feel like some .NET compatible language has the like, wait, this, I don't dot through this the same as I would a namespace. Like, this is presenting itself as being very different to me right now. And
I'm pretty confident nested types are part of the CTS, so I think you have to support them.
yeah, just is it intuitive
pretty?
or is it
Sure.
Yeah,
If we're gonna go the dedicated proxy type route, I like not having them be top level, because I think they're basically they're effectively an implementation detail of the type that we have to make public.
Exactly.
And so
yeah, I was gonna say, I think if you're doing something like a web method,
they're
go ahead, Emo.
So they're just like enumerators. There's really no difference.
I think if you're a web method that is just doing a one-shot lookup, is this cached, which is a weird, but like, I think some people would be fine just writing this, and other people may decide, I'll go ahead and save it to the field, even though the field is longer, or has a longer name than the dictionary type it would by, you know, this much, and anybody can do. Yeah, multiple styles are possible here. Some people won't ever see it. The people who never call in the thing would never see it. So I think if we want to go the proxy type route, which I don't know which way I feel personally, but if we want to go that way, I think nested types are fine. It's a power user feature.
Yeah.
To be clear, we're probably not going to name it. Go ahead, sorry, Tanner.
Go ahead, Steven.
Stefan. All right, now I'll go
Sorry.
just for that. No, I was just gonna point out in the if example, you would be writing out git span proxy. I doubt we're gonna approve proxy, but yeah, I still think a lot of people would be fine writing that.
I was just going to say, you can also use aliases with nested types. So if someone really wants to use it frequently, they can declare, using dictionary string foo span proxy equals dict proxy or whatever, and just use that.
That.
Yeah, basically. Yeah. Except you have to have it at the top of your file and whatnot.
Yeah. And I feel like it actually has to be fully qualified.
And when there's that many generic parameters, though, it's like kind of nice anyway.
So is this the direction, naming aside, is this the direction that people prefer?
No.
I prefer the original proposal.
I actually prefer the original proposal as well. I think the only spin that might be worth pursuing is just putting them in a separate namespace. But the problem with that is it has the same number of moving pieces in terms of types.
I prefer the proxy, but sounds like I'm outvoted.
What I don't like about the proxy is it feels very heavyweight.
Jeremy, you have an opinion?
I am coming out basically 50-50. There are elements that I like of each way. I appreciate with the proxy type that we've contained the failure. And once you've made it through the point where you have that type, you now don't get the like, oh, I accidentally gave you the wrong span type because I have too many locals. But at the end of the day, this feels like we're doing a lot of work to avoid a minor problem, at which point I'm back to like, the original proposal's probably fine. So, I'm of two minds.
So I see an existing type called collection extensions, but it's in the system.collections package, as opposed to like system private corelib.
No, we have one in corelib.
Oh, I'm
80% sure about that. We don't. I could be wrong.
What do we have in corelib?
No, we do. Yeah,
I know
system
there's a collection
generic collection extensions.
In corelib.
Yeah.
Yeah.
What's on it?
Getter default, I assume.
Get value or default, triad, remove, as read only.
Yeah.
According to APIs of .NET, it's not in private corelib. Or at least the projection of it. The projection of it, sorry, is not in system runtime. Sorry.
Yeah, it's in system runtime interrupt services, but like I think that all this collapses down system private corelib, right?
Yeah, it will. I'm just surprised that the projection's not in system runtime. But whatever.
And I know the original proposal works, but I like that this doesn't require a PhD in overload resolution to know that it works. And yeah, I really don't like it having the same names as more common methods, and then just failing at runtime in different ways.
Unless the chat feed has stopped, no one from chat has weighed in on liking one way or the other.
I think the one benefit of just a functional benefit of the proxy approach is I believe span would just work.
That's true, because there's now a targeted method that it realizes it can do a user-defined type conversion on.
Yeah. Which also means anything else implicitly convertible would just work. So if you had a char array, that would just work.
That's a good point. That might be making me prefer the proxy.
Why is that?
Because we don't end up feeling like we need to take these overloads and then further overload them like 400 times to make all the implicit conversions that we want to work. Array segment of char, array of char, span of char, all of those just immediately work because they're all implicitly convertible and
So you
happy
don't
to
have to
Why
call
would they-
as span on all of them.
But why
Otherwise,
would
overload
that
resolution.
be different from an extension method then? I mean, that still works in the extension method, right?
It doesn't know.
What do you mean? The
If,
extension method, you can't overload implicit conversions based on the receiver, but you can do it for any arguments.
No, but if you have a foo method that's an instance method that takes object, and you have a foo extension method that takes a read-only span of char, and you call it with a span of char, it will fail.
That's even though a ref struct can't become an object.
I'm 90% sure. I'll double check.
But even then, like I actually had in SharpLab a few minutes ago, like I had a dictionary of string object, and I made the contains key extension method, and I tried passing in a char array, and it said I can't cache char array to string. It didn't bother doing the conversion from char array to Raj char, and then saying, oh, it turns out I can't actually bind this.
yeah,
So we'd have to do the two
it's
overloads.
it's because all of our conversions across the span types are user defined instead of intrinsic, I think, because they get applied at a different time in function matching.
It's so
Yeah,
confused
like you
that
could-
it's like these are not the targets, right? This is all the actual parameters you pass into the extension method, right?
So the upshot is, if you had the extension method as it's proposed on the screen right now, and you literally had a Raz char and you were, slicing it, calling contains key, all that good stuff, that would work. But if you had a rented char array, for instance, and you were manipulating the rented char array, you wouldn't be able to easily pass that into this extension method. You would have to create an array segment from it and then call as span from that in order to pass it in. Like
Well,
you end up chaining a bunch of calls to get it to work.
it would actually
That's the part I
be
don't understand. If there's an implicit conversion from that to read-only span, it should just work because these are regular parameters. And implicit conversions are just will just work.
It can't match on the T-span element. That's the problem. The fact that it's a generic method and you're using generic type inference is the thing that breaks all of it. If the T-span element were actually, if the T-span element weren't there and the last parameter were Raj char instead of Raz T-span element, all of this would work. But because it's a T-span element, type inference just blows up at compile time. It doesn't know what you intended to do.
So there's nothing to do with extension methods here. It's just because it's generic. It's because it's a generic inside of the thing you want to convert to, and it can't do that.
Correct. It's the T-span element being a generic argument is the thing breaking it. If that weren't the case, everything would work.
Well, then how would the type proxy solve this? Because then they're just instance methods on that. So you have the same problem pretty much.
because instance methods will apply user defined conversions. It's generic inference mapping won't. Because
Well, wouldn't you still have them generically
'Cause, yeah.
inferred on the
if you specify all of the arguments, you've now told it, I want this to be read-only span of char. You've now forced it with the angle brackets, and then now it understands the conversion. But
Oh, you're saying
for
when you
it-
make them instance method, you don't have to specify the first two, so passing in the generic explicitly is okay?
no, if we do the proxy route, the method itself is not generic. The type was generic, which already encapsulated the last parameter. So now you have a non-generic function you're targeting.
Oh,
Yeah.
because I see the proxy encapsulates all three and not the first one.
Yeah. Steve put in chat a link, by the way, that demonstrates the problem in SharpLab.
Differently than the one I just
it
did.
demonstrates.
Because when I get rid of this, it fails to compile.
Oh yeah. It's the same thing in practice. Yeah.
I see. Yeah. It's the same.
Yeah, yours is a bit more explicit, Jeremy, but yeah, it's the same issue.
So I think that nudges me into favoring a variant of this approach. Where variant just means we figure out what the name should be.
I mean, yes, but I'm still not sold on the gazillion overloads problem, because in practice, are you really going to use them? I thought most of the people will just use the span here.
I don't understand.
So are you really going to try to use an array segment, or?
Really, this is about span and read-only span. I don't care as much about the array and the.
Yeah, which is what I'm saying. I don't think
expect
you will have a lot of overloads here that will be a problem in practice.
2 is already a lot, and if you have
Then-
to add one per span, it's annoying.
Sure.
Well, I mean, we've done that in dozens of places already.
Sure, but we don't need to.
Most of the places where
And
we
this
have read-only
covers more
span extension
cases.
methods, we have a span version as well.
It's better. Like in that it supports more than just span. It supports anything with an implicit conversion. And I do like the namespacing a lot. Having it as overloads on like basic methods, I think they're a little too specialized.
All right, so do we have consensus that we want to go with the proxy type route and that we're bouncing it back for that, or not?
I'm fine with that.
Yeah.
I wasn't motivated by the perf. I understand the usability. There are downsides, but I'm fine with it. And it has a slight perf benefit, which is always nice.
I just dislike the number of moving pieces this creates, but yeah.
Anyone have suggestions for a name other than proxy?
Span accessor or span wrapper.
Span view.
Span view. Yeah.
Span lookup.
I think I like span lookup the best.
Sure.
Yeah.
Okay. The one thing that I will add before it goes offline is, now that we've isolated it down to one place that can fail, maybe we want a non-exception variant. So I don't know if that's try get span lookup that outs the thing, or supports lookup of T element, or whatever. But just once we're going down this route, I think that there is the let somebody ask the question without the throw.
I mean, you can
You
ask the
could ask
question
the
by
question
getting the
either way.
concur. Yeah.
Well,
That's true.
Furthermore, like even with the other API, people might want to ask the question rather than just
That's true.
let it throw.
Levi
But, yeah.
reminded me I already had checked that somebody could do this with an is on the comparer
On the
property,
comparer.
which is why I was asking about it previously. So,
Yeah, just assuming that we make sure that we get all of the behind the scenes magic working, which we would want to do anyway.
Right. And if it
so this
is popular, we can add it later.
Yeah. So you have, this is still introducing the interface, right? What was that? Sorry, I lost
I
the
map
puzzle.
span equality comparer.
Yeah. So I equality comparer has, this comes back to what I was asking earlier. It has an in on the T argument. Do we need one here?
I don't think we can, because map would return T.
Yeah, T is in an out
You're
position
correct. Yes, you're absolutely correct.
T span element might support in, but I don't know that we've defined span as being. Well, I guess we can't have defined span as being variant because it's not an
It's
interface.
correct. Yeah. Okay. So no in. That's totally fine.
Yeah, I don't like this name, but don't have a better one off the top of my head.
Totally open to other suggestions. I don't like it particularly either, but
Yeah. Yeah, like I said, I can't think of one. Maybe I can background it, but okay. So the notes on this are: we want to go the proxy type approach uh, for collections, Marshall type things. I don't know that I have an opinion off the top of my head for whether this should take the dictionary or the lookup, because you're on collections, Marshall. You're shooting yourself in the foot anyway if it goes wrong. So whatever feels natural there.
I mean, if the struct already has all the information already in a single place so that you don't have to do the type checks anymore, like, you may as well just take it.
Because it would, if we take the lookup here, it would avoid another
Avoid
compatibility.
all the checks, yeah.
Sure. That's fair.
I mean, again, it's not the most expensive thing in the world, but like we're talking about types where people have shaved nanoseconds off because they care about it.
Yep. I want up through here.
Do you want to put the lookup name in the notes?
Is there concurrent hash set?
No. There's concurrent bag, but don't use it. No, it's good for some scenarios.
Is there a frozen hash set?
yeah, frozen set.
And that's going to do terrible, terrible things, isn't it? No, it didn't. Yay. And were there other types proposed up top that I missed? Dictionary, hash set, concurrent, dictionary, then the frozens, and we haven't ended on the for I mapped span quality compare. Or whatever it was. Okay, so bouncing that back. If needs work, and as you know, there's a comment of refactoring Frozen Dictionary will be fun. If the Frozens end up not working well with it, then we'll certainly cut it from the implementation, but from the API shape, I think we would say that they're included.
Okay.
It just feels like let's do it to all of our important types, especially if it's, hey, I made the frozen dictionary because this is all the things that will ever be valid, and I want to know if this span is in that cache or mapping table or whatever. So it makes sense to me that we would add it to all of our main keyed types. So, all right, well, thanks everyone for a very lively discussion on that one.
Thank you.
And yeah, so with that, we are a little bit over time. So thanks everyone for joining us online. I hope that you enjoyed watching the sausage get made on this one. And we'll be back next Tuesday, our same .NET time on our same .NET channel. Until then, auf Wiedersehen.